Math is a wonderful thing. Math is a really cool thing.
Alright, our next lesson is domain and range. So domain of a function is the set of all possible values of the independent variable x, whereas the range of a function is a set of all possible values of the dependent variable y. We usually write our domain and range using set notation. So what is a set notation? So for example, if I have W is a set of days of the week, we can list all the days in a given week. So W is equal to, using braces, we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we have here a collection of the days of the week. So using set notation, we are going to write this one as W equals braces X, such that X is a day of the week, wherein X stands for the elements, and we usually read this colon as such that, and this tells us what are the elements. Another example, let's say I have a set of first 5 counting numbers. We can write this, we can list all the numbers as 1, 2, 3, 4, and 5. Using set notation, it will be n equals curly braces x, such that x is a counting number less than 6. So let's have our first example. Remember that domain of a function is a set of all possible values of the independent variable. So let's say we have this graph consists of 4 points. If we are going to get our domain, we just have to identify all the 4 points that we have on the graph. So let's label the points. This one is your -4, comma, -2.
This one is -2, comma, 0. And then this point is -1, comma 1. And then this point is 1, comma 3.
So if I'm going to collect all the possible values, possible x values of these 4 points, we will have -4, -2, -1, and +1. And then we are going to include our curly braces. Now for the range, it is a set of all possible values of the dependent variable. So we just have to write all the y values. I'll start with -2, 0, 1, and 3. So if we have a graph consists of points, finding the domain and range is just matter of listing what are the x values and what are the possible y values. Alright, next, what if we have a line or a curve? How are we going to get the domain and range of a given line or a curve? Note that line, just like this, is a collection of points. So we can have this line actually consists of a lot of points. Okay. And even between these 2 points, you can find another point. So we have a lot of points. This line is actually a collection of so many points. We have infinite number of points. We cannot count all of them. Alright? So if the domain is a set of all possible x values, and we have a lot of points, and there's no way that we can list all the x values. So how are we going to find the domain and the range? Well, the best way is to use our set notation, and we are going to describe what are these x values in terms of the domain and what are the y values in terms for the range. Now before we start, let's describe the following graphs using set notation. Note that we had this graph before when we solved problems like inequalities. And once we have our inequality, we usually write our solution set using this graph. So let's describe what are the x values, or what are these numbers. Okay, so from 0 all the way to the left. Okay, now pay attention to the 0, or pay attention to the circle that we have here. This one is a solid circle. It means that 0 is part of the solution. Alright? So when we discussed inequality before, when we write our solution set, it will be x less than or equal to 0. Whereas for this graph, it will be x greater than, without the line under, because we have an open circle, x greater than 2. Now using set notation, the only thing that we have to add is the curly braces and then say x such that x less than or equal to 0, and then curly braces. Or this one can be written as x such that x greater than 2, curly braces. Alright? Now what if I have this solution set? Okay, how are we going to describe the values here? Now pay attention again to the endpoints. This one is a closed circle and this one is an open circle. So the solution set here is actually from all numbers from -3 all the way to 4. -3 is included, but 4 is not included, and all the points in between these two numbers. So how are we going to describe this? We'll start by writing -3 here, and then writing 4, then write your variable here. Let's use x. So to describe all of these points between -3 and 4, -3 included and 4 not included, we are going to say x is equal or greater than -3, x is less than, and this is how we are going to describe this solution set. So it's just all x, all numbers from -3 to 4, including -3 but not 4. Okay, what about this? Now again, pay attention to the endpoints. So this one is a closed circle, this is a closed circle. It means that all the numbers from -3 all the way to 2, including the endpoints -3 and 2. So how are you going to write this? Using inequality, it will be start from writing this endpoint -3, 2. So x is greater than or equal to -3, less than or equal to 2. Okay, what about this? So again, write the endpoint 1. This is 6. So your x is greater than 1 without the line under, because this one is an open circle. And then x less than or equal to 6. We have the line under because we have a shaded circle here. And finally, if we have two endpoints that are open circle, just write the endpoint -4, 1. So your numbers are actually between -4 and 1, and -4 to 1, excluding the endpoints -4 and 1. So we just have to write x greater than -4, x less than 1. To write this as a set notation, well, just use your curly braces. X such that, so same thing with this, x such that. Now sometimes instead of using a colon, we can use vertical line. So this one is x such that x is greater than 1, less than or equal to 6. So this one is x such that x greater than -4 and x less than 1. Alright, so that's how we write our set notation. We are now ready to describe the domain and range of line or curve.
Math is a wonderful thing. Math is a real